Okay, before I continue with example 2, let's recap the key steps required when we actually handle a proof by mathematical induction. Step number 1 is always to prove that P1 or the first case is true. Thereafter, we attempt to prove that if PK is true, then I can prove that PK plus 1 is true. So this is roughly the procedure. Okay, so I'm going to run through example 2 now. This time around, we're going to do mathematical induction using recurrence relation. Okay, so read the question, okay, and thereafter you continue with what we have. So you have a sequence of numbers such that u1 is equal to 1, and this result. Proof by mathematical induction this result. Okay, so there are a few things that has been displayed in the question. Please rather read very carefully what you are expected to prove. Which one is to prove by mathematical induction? It is the orange section. Okay, so step number 1. Okay, I'm repeating the steps one more time. Make your definition. Okay, let Pn be the proposition by which what you're expected to prove. Okay, this statement is necessary. State your proposition, Pn be blah blah blah. Next, prove the left hand side and right hand side of your first case. How I know who is the first case? Look at the question. Okay, I have u1. Okay, so first case, left hand side is equal to u1 is given in the question. On the right hand side, okay, on the right hand side, when n is equals to 1, that will be my first case. So what I'm going to do is I'm going to replace all my n by 1, and I'm going to end up with 1 multiplied by 1 over 0 factorial. Okay, and the result is equals to 1, and it will be equivalent to the left hand side. So in this case, what you have done so far is that you have proven that P1 is actually true. Step number 2, make an assumption now. Assume PK true for some k value greater than or equals to 1. So the assumption is that UK is going to be this result. So again, take note, it is actually exactly the same as your proposition. Only difference is that I'm replacing n by k. Step number 3, you need to show that PK plus 1 is true. So always find out what you are expected to prove on the right hand side. So focusing on the right hand side, okay, UK plus 1 is expected to be equals to k factorial. So summation from 0 to k, 1 over j factorial. So this, focus on this, just add 1 to this. This, add 1 to it. Okay, that will be your right hand side. Then the left hand side. The left hand side is actually equals to UK plus 1. So what to do with this UK plus 1? UK plus 1, I need to tap on this result here. I have UN plus 1 equals to NUN plus 1. So UK plus 1 will be equals to K UK plus 1. Okay, it will be equivalent to K UK plus 1. Then, okay, what is UK? UK, by your assumption, is equivalent to this. Okay, make use of your assumption and replace accordingly. So k times of this whole section, which I can copy down. Okay, this whole yellow section is technically taken from this orange section. What you do need to do next is, of course, combine. Okay, simplify, and then take note, where is my end objective? This is my end objective. Work towards this goal. Okay, so of course simplify. First thing, combine. K multiplied by k minus 1 factorial is actually equivalent to k factorial. Then, okay, look at what you have. I still have the 1 to get rid of. Okay, in order to reach this final stage, I still have the 1 to take care of. So what to do with the 1? Factor out your k factorial, then introduce with a 1 over k factorial. Okay, so now focus on this yellow summation, and of course this in green. Okay, they are actually of the same form. They are actually of the same form. I can combine them into summation from k, instead of k minus 1 is actually summation from 0 to k, which is actually the right hand side of pk plus 1. Okay, then of course after that, do not forget your conclusion. So what you have proven is, if pk plus 1 is true, then you have implied that pk plus 1 is also true. So since p1 true, pk true, imply pk plus 1 is true, then by mathematical induction, Pn is going to be true for all values of n which is greater than 1 now. Okay, then of course the last part of the question has nothing to do with mathematical induction. It's a matter of analysis. Okay, state an approximate value of this result. So this result, nothing really fantastic. Okay, if you actually observe a bit, okay, it's actually, it comes from these and this. Okay, so do a division, you actually realize that that result is actually summation. Okay, that result, this thing is actually equivalent to this thing in yellow. Then of course expand out this section in orange, and you realize it's actually 1 over 0 factorial over 1 plus 1 factorial, blah blah blah. Okay, and this, okay, I can't say that how I'm going to teach you to do this, okay, but this is one of your special results from your Maclaurin's expansion. You can actually see it from MF26, the expansion for EX. So in this case, it's actually E1. Okay, in this case, it's actually E1, Maclaurin's expansion for E1.